Hi there. This screencast is to supplement the existing screencasts due to what the tutors have observed within the week 2 sessions. Specifically, I'm going to be touching on arrays and addressing. So here's Assessable Task 3 that we had running for Lab 2, and I'm going to be using these existing arrays, wins and goals, just to demonstrate a couple of things before I move on to the solution for these three from Assessable Task 3. So if I go to MATLAB, I've already put these into a script, and I've got a CLC up the top just to neatly clean the screen when I want to. Okay, so if I was to run this, nothing will happen because there's nothing to display, there's nothing to execute. All it does is it assigns these array elements into the array wins, and the same goes for goals. So now they exist in my workspace. So I'm not sure how everyone feels about the concept of arrays and elements within arrays, but I'll just touch on them now. So I have the array wins here. If I wanted to only use the first element of the array, which is 5, I need only to call it like so. So 1 corresponds to the element I'm interested in, and the brackets say which address range I want. Okay, so I want element 1 of wins. That gives me 5, of course. If I wanted element 3, I could do it like that. If I wanted a range of numbers, say 2 to 4, that would give me these 3 numbers, and the result is actually a new array. So remembering that this colon operation here, 2 to 4, generates the numbers 2, 3, and 4. If I was to type in wins 2, 3, and 4, it doesn't quite work. Okay, there is a slight difference, and this is because this is an array, and this is not an array. Okay, so wins 2, 3, 4 is not the same as wins colon 2 to 4. Alright, get rid of that. So now I want to take you through the concept of the length function. Okay, so we have here an array and it has 5 elements in it. We can see that pretty clearly as human beings, and luckily computers can too. Because we've declared it with 5 elements, we can use the MATLAB function length of wins, and the answer it gives us will be 5. So we should use this. Now, on to the problems. The first one is to calculate the average number of wins and goals per season. So there should be one number from the wins and one number from the goals. If I had a perfect run, I would have 10 wins for each one of these seasons. Each number corresponds to a season, and there were 10 games played per season. A season is also a year. So my average in that case would also be 10, because 10 plus 10 plus 10 plus 10 plus 10 divided by the number of seasons played will be 10. Okay, so all I need to do to calculate the average is add all of these numbers divided by how many numbers there are. How can I do this? So we've seen within Lab 2 the use of the for loop structure. So let me begin by typing the for. I like to use the index variable I, so I'm going to type I, and it equals 1 to the length of wins. Why do I pick this range? Because 1 will start us here, and length of wins will take us all the way to the end. Okay, this will print a range of numbers 1 through 5, 1 for each element in the array. So this is probably what I want when I want to add each number in the array to each other. Okay, so for now I'll say disp I, and before that I'll make this even better, and I'll say I equals, just for context, disp, I'm going to say wins I equals. So if you've seen the screencasts already, you'd be aware that the difference between the strings and the just pure variables there is that this is always going to print no matter what the value of I is, even if I doesn't exist. So now I want to display wins I, whoops, and end. So let's run this code now. So the first time through the loop, I equals 1. That's fairly standard. We get this message, I equals. We get 1 for when I equals 1. Next we have the message here, which is reflected here. And then we have this, which happens to be 5. So the first element in my array is 5. The second element in my array is 6, 7, 4, 5. Okay, so this is actually printing out each number in the array. Let's modify this so that we're saving the numbers. So I might just comment this out for now. Actually, I'll leave this one uncommented and leave the rest of that. Okay, what if I say something like sum equals wins I? And down here I'll display sum. Disp sum equals disp sum. Okay. Also give this a little bit more context, forgive me. Alright. From the top, I equals 1, sum equals 5. I equals 2, sum equals 6. That's interesting. 7, 4, 5. My final sum is 5. So what is the problem here? The problem here is that we're not actually adding anything. I just made a variable called sum, but I'm not adding anything. I'm just making it equal to whatever the current element we're up to is. So we're actually kind of doing the same thing we did here in here. But instead I actually want to add numbers. So let me clear this sum. So sum no longer exists. Let's do this. You would have seen this in lab 2. I get an error. Okay. I equals 1 runs just fine, but it hits this error. I can go to where the error is by clicking on this link, line 12, and it's here. This error is actually a little bit misleading. It says not enough input arguments. I don't find that very intuitive, but the actual problem here is that you're trying to use a variable before you're even declaring it. Okay, so MATLAB is happy to say sum is equal to something, but then you're saying it's equal to sum. What is sum? You haven't specified it up here. It doesn't exist in here, so it has nowhere to start. That is why we have up here sum equals 0. So before we start, it can substitute in 0, wins I, and then do another loop. Okay, so let's see what this does. The sum is 5 because the first element is 5. The sum is 11 because it's 5 and 6, so on and so forth. Our final sum is 27. That's great. That's what we want. To generate our average, we're going to need to add up all those, and we're going to need to add up all of these too. Luckily, this is fairly straightforward. I could just copy paste this and do it for goals, but that's a little bit clumsy. Instead, what I'm going to do is modify my sum variable, and we'll call this sum w. See, there's this handy shortcut here. I'm not sure if this exists on all the computers everyone's using, but I'll just go ahead and use this because I would do that manually anyway. Now I'll make a new variable sum g. So sum w for wins, g for goals, I equals this. I'll make a new expression very similar to this one above me, except it's adding goals. Now we're fairly confident this is working at this stage, so I'll just delete that. And I'll say sum of wins is equal to, copy this. Oh, whoops. And this will be sum of goals. Okay. And there we have it. Fairly straightforward. This doesn't seem to serve any purpose anymore, so I'll just delete everything here. And now we have fairly compact code. With a little bit of commenting, it'd be fairly straightforward to read. But this is not the average yet. This is just the sums. So how do I get the average? I add up all of the numbers in the arrays and divide by the number of numbers in the array. So I divide by the length of wins. Divide by the length of goals. Note here too that I'm using the length of wins for both the wins and the goals. This is a fairly reasonable thing to do for this problem because we're assuming that the same number of seasons is for wins and goals, okay? So if you had more goals than you did wins, then your problem is a little bit ill-defined, so it shouldn't work anyway. Now these messages are wrong, so I'll just say this is average of wins and average of goals. And hopefully these numbers look familiar to you from the lab. That's the correct answer. Okay. On to the next problem. The number of goals per win for each season. So how do I generate goals per win? I just simply divide number of goals for that win. So it says each season I should get 5 different numbers because there's 5 seasons. So for the first season, my number of goals per win is going to be 27 divided by 5. Second season it's going to be 34 divided by 6, and so on and so forth. Okay. How can I do this? Well, maybe I should start with another for loop. Notice here too I'm using I again. The fact that I've used it before is irrelevant because when you finish I will be equal to 5 because it exits the for loop at 5. But if I just started again from 1, I'm effectively recycling the variable. It doesn't make a difference. Okay. So I might do here a simple display of goals, element I, because I want to take this number and I want to divide it by the number of wins in that same season. So when I equals 1, I want this number of goals and I want this number of wins divided by each other. When I equals 2, it'll do this, and so on and so forth. So I could put some text in there to give it some context, but there you have it. So this belongs to that, and this is what I just did. So this is what you should get for your second part to this problem. Hopefully that was fairly straightforward. Now, if you're clever, you would notice that these arrays, you're basically dividing one element by the first element here, the second element by the next element here. So there should be a straightforward way to do this, and there is. I can comment this, and you would think that it'd be as simple as maybe something like goals divided by wins, but actually this isn't correct. This result isn't something you should worry about right now. And you know it's wrong anyway because you expect 5 different numbers. You're only getting 1 here, okay? So what MATLAB has is this dot operator. So I can do a dot plus, a dot times, a dot divide, or whatever. And what this will actually mean is I want to take the first number in goals and divide it by the first number in wins, so on and so forth. And what it gives me is an array that's the same size. So each number has been divided by the other, and you can see the answers are still right. Okay, so I've commented that out. I'm just going to say disp goals dot slash wins. Very good. Now onto the last problem. Computers cannot make simple decisions like humans can, so write code to find the largest number in a list of numbers to prove that 2009 had the most wins. Don't worry about this for the moment. The problem here is that we want to find the largest number in a list of numbers. Okay. How do we start? I have a particular algorithm, but there are many algorithms you could use, so feel free to do whatever works for you, but this is what I'm going to do. For a start, I say max is equal to 0. What is max? Apart from the MATLAB function, I'm going to use it as a variable. Okay, so max is going to be the maximum that I end up with. Alright, so it starts at 0. Of course, it's not going to be 0, but I need to make it 0 before I can get started. So I need another for loop. I'll make a for loop with I, once again, to length. Now, I'm emphasizing this because we need to do it the same amount of times that the array is long, okay? If this had 10 elements, I need to do this 10 times, but it has 5 elements, we will do it 5 times. I need to compare each number to see which one is the biggest. That's why we do a for loop over each number, okay? So at this stage, I ask myself a question. The question is, if wins I is bigger than max, so if the current element we're up to, for the start, it'll be the first one. If the first element is bigger than max, which is 0 at this stage, 5 is bigger than 0, which is true, we want to say my new maximum is wins I. And that's it. And I'll display the max here just for fun, and end it. And then I can say disp maximum is disp max once again. Okay, the output's looking a little bit clumsy here, but this is pertaining to this section of code. Okay, so we have 5 numbers here. First time through, it says that wins I, i.e. wins 1, is bigger than max. So max is updated, max is printed. At this stage, that will be 5. That's why 5 appears first. Second time through, 6 is bigger than 5. So max is updated. That's why we see 6. Then 7 is bigger than 6. Max is updated once again. We display it. But because 4 is smaller than 7, this bit of code does not execute. This statement is not true. We display max because max has not been updated. It still remains 7. And again, we exit the for loop. We come down, display this message, and display our final maximum. So in that way, we have determined the maximum number in an array. Okay, so hopefully that was fairly straightforward. Coming back to the problem we had for Assessable Task 3, we wanted to prove that 2009 had the most wins. So realizing that 2007 was the first year played, and that corresponded to 5 wins, we want to say from the computer that this year had the most wins. So we know that this is 2009 because that's 2007, 2008, 2009. How can I get the computer to do this? Okay, so by comparing the difference in the array index, this is index 1, this is index 3, I knew that this was 2009. So the index is important. I'm going to make a new variable, max I, for index, and I'm going to make it equal to 1. I won't explain why this is, but hopefully at some stage you'll understand why I made it that way. If we found a new maximum, we should update our maximum index to be I. So the maximum is wins I, but where that maximum occurs is I. Okay? If this was J, then that would be J, and that would be J, so on and so forth. Okay? So the maximum number store is this. So what I can do instead is say maximum number index is max I. This should of course tell me it's 3. Very good. This is still displaying maximum number, not a big deal. So now I can say year with most wins is, and I'll say 2007 plus max I. Will this work? It won't, because it says 2010 is the year with the most wins. And why is that? It's because if the maximum number happened to be in the first element, the maximum number index is 1. I'm adding 1 to 2007, I get 2008. In this case, maximum index is 3. I add 3 to 2007, I get 2010. So I just need to subtract 1. And now it works. If I alter the program, if I make this 25 say, even though that isn't outlined in the problem specs, we didn't play 25 games, it'll still update correctly. 2007, 2008, 2009, 2010, 2011 was the year with the most wins.